Welcome to Envio Shipper Log. My name is Dimitri and I'm here with a new version 2.32 with a lot of nice changes. So let's begin. The first and a big one is Effect API is no longer experimental. It was released almost half year ago and we use it well. A lot of you use it well and it served its purpose, and they actually remove this experimental prefix without doing many changes for the API itself. Like there were a lot of work to make it more reliable, stable, but the API didn't really have many major changes, so you can safely remove the experimental prefix from your Effect API calls, and the only change you'll need is to explicitly set RateLimit, and RateLimit is a new feature. But let's stop here and have a short and a quick introduction to Effect API itself. And for those who don't know, in Hyperindex, if you want to make any external call to get data using RPC client or IPFS data or requests to an API to your server or anywhere, or just send data to Kafka. So any external call from your indexer, you can do it normally, but then since we guarantee that all events in Hyperindex will be processed sequentially, it will be slow. So as a solution, we provide this Effect API, which works really nice together with the preload optimization, which allows you to perform a lot of external calls in parallel and do it fast. Also, it has integrated memoization logic, so you don't have duplicated calls with the same input arguments, and as well as a nice integration with the built-in caching solution, and also now it comes with a rate limiting. So let's take a look at new changes. So compared to the experimental version, the only difference is now rate limit is required, and rate limit you can set it to false if you don't want any rate limiting. If you hit a really reliable service which don't have any restrictions and you don't afraid to overwhelm it is a bunch of requests, because Effect API might be called 1,000 times a second. So you should be aware of this. And if you're not sure that hazing point you're hitting is going to survive this amount of requests, it's better to configure rate limit. And if you want to configure it, you can pass an object with two fields. Is calls per second. Also, it can accept minutes. So it can if you have rate limiting not in RPS but request per minute, you can also set number of calls per minute, and alternatively you can provide a number, an exact number of milliseconds if you don't want a second per minute. And yeah, this is one of new changes with this version. Another one that now you can configure whether the cache should be saved or shouldn't be saved for the exact specific Effect API call. So in Effect API, there is a cache option, which is optional. And if you set it to true, this get metadata Effect API call before actually running your function, provided as a second argument, it will first check that whether there is a value with the same input already stored in cache table. And if it's stored in cache table, it won't perform this call. So this is a really nice way to save time when you're developing or when you're running your indexer, and you can pre-populate some initial data in this cache to save some, for example, RPC credits, or just to save some indexing time. But there could be cases where you perform a request and get an error, but you don't want your indexer to stop indexing and crash with this error. You want to provide some default values, but also, for example, want to retry it in the future using a block handler or something like this. Previously, he would return undefined or some other default value for his effect API, and it will be cached in the cache table. And if you retried to update the data, there wouldn't really a nice way to do this, because the result will be this default value will be immediately retrieved from cache without an actual retry call. So now it can be written by setting context cache false for a specific call. Also, it can be done vice versa. If you have cache false for all metadata, get metadata effects, you can set it to true for a specific one and cache some specific results, but not caching all the other ones. So this is nice thing. And let's go to the next addition for this release, and this is a development console. And we have a really nice tool which you can access by going to the Envio Dev console, and it have a lot of insights for development and just tracking the progress of your indexer you're running locally. And now it got a nice addition, and this is really detailed insights about the effect API calls and also about getting data from storage. It includes the entity get calls, also it includes getWhere, and all of them are broken down in this nice interface. We'll come to this a little bit later, but for now let's go to the last feature of this release, and this is a getWhere lower than. So previously in HyperIndex you get retrieve an entity by using an entity ID, using entity.get, or also like there are some variations, getWhere throw, getWhere create, which are also nice. And if you wanted to get an entity by some field value, you'd be able to do this by calling entity context.entity.getWhere.field. And you had two options before: equal, and to find to retrieve some entities where some field value equal to the value you want, or greater than. So equal or greater than were the only two available, and now in this release there is also lower than, which I think is really nice and has its own use cases. For example, you want to get some entities with creation timestamp lower than a week ago, and you can delete the entities, so you can save some space in the database using this way. And you can put this logic in a block handler and run it like every day and clean up some relevant entities. Like just an idea for you. And yeah, this might be a little bit confusing, like why is this effect API needed and anything like this. If you have questions like this, I definitely recommend you to check out our documentation. You can access it by clicking docs on our landing page. And here in the advanced section, there is effect API, and especially I also recommend checking out the preload optimization and also taking a look at this preload optimization video and explain why effect API is such a great thing. And for users who already know what effect API is and how to use it, I just decided to go a little bit in details and show you how I use it in a real world. So I got an indexer here, which was written like a year ago, and it was using version 2.6, and I already upgraded it to the version I'm currently showing to you. And I'm going to migrate it from the things how we like did it 1 year ago to a modern hyperindex features introduced like in all these versions we released for this last year, and show why it is amazing. It also shares some really nice tips and suggestions which you might find useful in your hyperindex development in the future. So let's continue. And I said that it will be useful for people who already used Effect API, but I'm actually wrong, because if you didn't use and you wonder why you probably might need it or how it might be useful, I think this part of the video will be interesting for you as well. So let's continue. Okay, it's going to be quite some coding now, but before I start, let's take a look at what's going on and how it was developing a hyperindex a year ago. And we start with a config file. And what this indexer does, this is a UNIF3 indexer, which actually indexes only a single event, and this event is pool created. And when we index a pool created, we would create an entity pool, and also we would create two entities with token stack. One entity for token 0 and another entity for token 1 of this newly created pool. But what makes this indexer interesting is that it was retrieving the token metadata from an archival RPC node and get name, symbol, and decimal for the token, which is part of this pool, and he uses metadata to store into the database. So we can get an actual name, symbol, and decimal of the token in the pool. Like this is a quite common pattern. We use it in Uni v3. Also, you can use it in Uni v4 and quite many other indexer solutions. And previously, this was done by doing a normal function call here. And yeah, and the problem is that external calls are slow. As without preload optimizations, they're even slower. So what this indexer did, it was using some custom caching solution. And if we take a look at the code quickly, let's scroll through. Yeah, it was quite wild. And a year ago, it would require you either copy paste it from somewhere else or came up with your own caching solution, which was not nice. And what it did, it actually would create this JSON files. And yeah, using JSON to store a bunch of cache might be simple at first, but it's actually not best because you can't store into it a lot of data in JSON files. So you need to create multiple JSON files. Also, it takes a lot of time to load and write updated cache to it. And yeah, we actually had a lot of problems with solutions like this because they could easily kill indexers out of memory just by simply loading a single file from memory. So yeah, this was a reality a year ago. And yeah, and another problem is performance, as I said, because if you watch a preload optimization video where I explained it quite a lot in details, but we guarantee, and this is important because without this guarantee, it would be hectic creating indexers, and you would regret this choice, like going into development at all. So without this guarantee, it would be really pain. So we really guarantee that every handler runs in order and it's sequential. So if you do context, how can you get something? You can be sure that if this token was created by the previous event on chain, like the previous pool created event, you'll be able to get it from this call. So this is important, and because of this, all this get token details calls will be called one by one, and I'm going to show it to you now. So I'll start the indexer with this version, and let's go to the development console I already have here, and you can see that it will take a while. So I'll wait for you and until it processes a few events, so I can show you how slow it is in this current implementation without using Effect API. Okay, it processed a few events 500 events, and you can see that it already took a minute, and out of this minute, this pull created handler took most of this time and processing 5 events per second. This is crazy, and we don't want this, so let's go to the code and change this to use effect API and see how faster it is. And before we do this, I actually realized that in the config, there are two things. Like, first of all, rollback on rework set to false, and I don't know the reason, but probably a year ago it wasn't this reliable, and this is not true anymore, so we can remove this and it will use rollback on rework automatically. And currently there is no reason not to use rollback on rework feature, because you don't want to have corrupt data in your database. So definitely set it to true, or just remove it from the config YAML and it will be automatically set to true. And another thing I want to enable is preload handlers. Yes, we want to have preload optimization. But what's important, if I keep it like this, without any other changes, it will actually become probably twice slower. And the reason is that now this handler will run twice. And without any memorization or caching, this getToken details will be called twice. And actually I'm wrong here, because there is caching, but this caching implementation is done this way that every time it's called, it tries to write this JSON file. And if we run a bunch of events in parallel, it actually might crash this indexer with preload optimization enabled. So it will make things even worse. But this is not a problem. We should worry, because we are going to just come here, kill this cache file. We don't want it anymore. This was also a nice cache with a lot of data, but let's also kill this. We also not need this anymore, because effect API comes with a built-in cache, which is much better than this whole solution. So, and how we change this to effect API? And a good news that we don't need to change a lot of code. We just need to add some additional function calls. Before this, I want to stage these changes, so we after we are done, we can see the beef. And also I'll zoom in a little bit here. So let's remove some old infos, and I'm going to dive into coding a little bit. So bear with me. And yeah, to use effect API, we need to define the item effect. And usually you do this, like some people prefer to adding an effect suffix. I just call it like this. Okay, let's add an effect suffix. There's no how to call this. Yeah, there's no start or something like this. Yeah, and now what we do, we call create effect and import it from Envio package. It accepts two arguments. The first one are options, and the second one is a handler. And for a handler, okay, let's just do like this, so it doesn't complain. And options are we can the options are an object, and we can see suggestions here by press Control space to see a list of suggested options. And there are actually a lot of required one, like 4 required options, and cache is optional. And let's start with name. And name is really nice thing for debugging, and it will allow you to see how useful it is in a second. So yeah, we set it to getToken details. Or let's actually call it, okay, let's call it getToken details, but usually you'll probably call it getToken metadata. I don't know a year ago why it was called getToken details. Now, if you take a look at a lot of our current indexers like UniU4 or indexers you built, you'll probably see getToken metadata name. For input, yeah, input is a schema which defines the type and the shape of the arguments that the token effect should take. And it's actually very similar to type definition, but it's not really type. It's in runtime, and it uses a schema, and under the hood it uses a schema library called Suri, something like this. Actually, Suri version 9.3 at the time. Hopefully we'll upgrade it later, but it will probably happen in hyperindex v3. So not soon. So if you have any questions or you want to get some more information about what's going on here, you can go to Surrey documentation and open this version specifically. Okay, and how to define this? And it's quite simple. If you're familiar with Zod or other schema library, you might find it familiar, but it should be even simpler here. So for input, we want to use the same arguments as the previous getTokenDetails function, but use an object this time. And yeah, to define an object schema, you just pass an object here. Alternatively, like it's the same as calling a schema. But not. Let's keep it simpler. And here, I'll just copy this and add an S module here. And S is imported from Envio. So this is nice. A huge TypeScript error message, but it doesn't lose anything bad. So let's do the same for the output. And output is the promise of a token details. And in fact, this is pretty much the same. Like here, we had to define the types for a function definition, but here, instead of defining types on function definition, we do this by using a schema. And then the types will be derived automatically from it, but also it will like there are a lot of nice additions, like to be able to persist this data in cache and anything like this, which you shouldn't really worry about as either. So I hope it won't be difficult to figure out how it works, because we are really close to be done. And for RateLimit, yeah, so I'm really close to finishing this for required fields. Let's say we want to start this RateLimiting and link, then close after second. I think this is good. And let's also cache the data, because why not to do this? And now I can see that, oh, it says to return promised null, but I actually expect a promised name symbol decimals. Yeah, this is a valid point. Actually, one more tip here. Yeah, probably this section will be long, but I'll share some tips with you. For example, if you want to reuse this type anywhere else, what you can do, you can copy this and say want to create metadata schema and use this schema and pass this object inside of the schema. So now we have this metadata schema, and you can pass it to the output here, and it will be exactly the same. So literally the same code here. And also you can get the metadata type by calling sinfer on the type of metadata schema. And yeah, I think this is really nice. We don't need it in this case, but theoretically, if you use it in other places, you would be able to do something like this. And yeah, this is nice. Okay, it complains, and what we do here, we just come to our auth logic, ignore the part related for cache, and yeah, also don't need to have this cache add anymore, and just copy everything, delete the old code, and let's place it in our get tokens token details effect. Nice. So now it complains that we don't have contract address or anything like this, and we can get it from input. And let's spread our data here. So now I have contract address, chain ID, and pool. And what it complains about, and it complains that we don't return our effect API. Like we return void, but it expects name, symbol, and decimals. And this is another reason why it's nice to have this schema definition here. It also helps you on type system level. And TypeScript errors are crazy. I have a tip for you. I read it from the end. Usually it helps. So let's fix the error. And yeah, instead of creating this entity, we'll just return it, and we also don't move this as closed. Yeah. And let's fix some additional type errors and continue with our upgrade here. So what does it say? Property contract address doesn't exist on type contract address. This is a word here error. Aha, okay. It's on contract address. Yeah, makes sense. Thank you very much. And nice to use a type language. I wish it was REST. Yeah, sorry. So I think we are done here. And what we how we use this get token effect, because this is not a function anymore. This is an effect with input and output, like an effect which accepts this object and returns this object. Yeah. And an answer is simple. We will go to our handlers and change this get token details to get token details effect. And instead of calling it directly like this, now we call context that effect and pass this effect as a first argument and an input which it accepts as a second argument. So now it accepts an object. A nice addition here is that you have some sort of labeled properties. So it's less likely you'll have a mistake when you pass an argument in a wrong order. So what doesn't it like? Doesn't like. I think I didn't add an expert. Yeah, I didn't add an expert here. This makes sense. So now it doesn't open anything. And let's copy this, paste, and replace token 0 to token 1. So it is correct. And before we run this indexer, actually, now a few gotchas here. And if you take a look at this get token details or get token metadata, whatever, this is actually quite tricky. And Subliter team written a nice article explaining all these glitches about properly getting this token metadata. And you can see that we actually use VM client here. And what's nice about hyperindex, you can use any library from it. It doesn't it runs in Node.js. It doesn't restrict you about anything. For example, like subgraph, which is an assembly. Yeah. So here we do a multi-chain call. Multi-call to get decimals name and symbols using the normal ERC20 ABI. But then if it fails, we also check the ERC20 bytes. There are a few gotchas where we need to the data might be corrupted, and it might come with some symbols which can break right into the Postgres. And actually, I know that it might happen not only for this call, it might also happen for this call. You don't want the index to crash. So there are some people who create some trash tokens which really want to crash your database when you're indexing. So we don't want to allow this. And for this, we'll include this replacement here. Also, another crazy thing that there are indexers with decimal, some tokens which return decimals some crazy number which is even exceeding any imaginable size, and it also breaks the indexer, and because it exceeds the numeric size and polarization. Numeric allows quite a lot of quite big numbers, and you can just imagine how big a decimal can be if it exceeds the numeric. So to prevent this, we will also add some checks here, and let's check if decimals are. I think first of all I want to check that it's an integer. Also I want to check that it's positive and that it's like some same number. Actually, 18 makes sense, but I also saw in like tokens with decimals at 50. And I think if it's more than 50, then it's something crazy, and we don't really want this. So let's allow tokens with decimals. Yeah, with decimals. Sorry, with decimals below 50. And if it fails, then let's take a look at the logic. It will log and yeah, continue without an issue. So we are fine here, and we can say if it's throw an error here, it will be yeah, it will be logged. But I actually don't like what's going on here. Like this is an year-old code, and for example, if you have this replaced here, you can remove this. And because now Hibernate handles this automatically, so you can replace this removals here. It's a little bit different story from this character. Like this character is not handled by Hibernate automatically, but the one I removed from handlers is. And also, like console log is not good because it won't be propagated to the host service or anything like this. So let's use context log error instead, and it will automatically include the item to the context, so we don't need to explicitly pass it here. And what we can do instead, we can pass error as error like this, and also let's do it here. And I think it can be a warning because it's not like a super critical thing. So we are done, and I think you should be curious how it runs. And I am. So let's run. Let's try it. Let's go. I'll do this by running Envio start, and I'll use this -r flag to restart and clean the base space. And it's going. So let's open the Open console, and you can already see difference. And I think first, it's not running faster. And I tell you the reason, because now you can see what's actually going on with your Unixer, and this is a new feature with this, by coming to this version, an enhanced effects API view. Previously, it was showing only calls, but now with this version, it also shows the time it takes to run this Unixer. And we can actually see that it's not regressing because a lot of events are simply queued, and yeah, and the problem is rate limiting. And we can also see that 56 seconds of the indexing time was taken by this get token details call. And if you want to optimize, we can easily understand, well, probably this is a problem of this indexer, and if you want to make it faster, we probably should improve this part. And it's not that difficult, because if you hover over this, you can see that this is how much processing time was spent waiting for this effect, and only 11 seconds was taken to actually call the FATP function, and an average 112 seconds per call. Quite useful information, I have to admit. And a minute and 30 seconds was taken just thinking a queue. This is not nice. So let's actually remove rate limiting, because I use a quite nice RPC for this indexer, and yeah, we don't really need this first case, but it just shows that it works. And if you want to protect and it makes sense for you, definitely use this feature. But in our case, RPC doesn't have any rate limiting, or it's not a problem, so we just remove it. And actually, let's stop it. You can already see that it started running much faster, but I remembered one more thing. If you use a VM client, there is a really nice feature which Effect API allows you. And what's nice about Effect API is that it automatically batches calls performed in multiple handlers memorializes it and does a lot of similar things, but also it really works nicely with VM transport level batching. And to enable it, you can do you can pass a second argument to this HTTP function and pass batch through. There are also options to pass batch size. Some RPC providers allow a batch size of 100 or 1000, or some RPC providers don't allow transport level batching at all. So we need to be aware of this. But in most cases, you can set batch through in VM transport level here. And like you can see that there are different batching. This is VM transport level, and this is an like multi-call batching. That's a little bit different things. Yeah, and what it does, let's say this effect API call is called 500 times at the same time. And these 500 calls, instead of doing 500 HTTP requests, they will be grouped in a single huge HTTP request. And this is usually optimizes things quite a lot as well. So let's start the Elixir and see how it goes now. Whew. Yeah, it's going. We still can see that getToken details takes most of the time, but now as the progress goes much faster than before, and yeah, we already performed 7,000 calls. It's already 8,000 calls. Goes quite decently fast, and let's wait for a minute to see more relevant results. And actually, that's interesting that our data source is being slower than performing all these external calls. So we are getting the events slower than actually setting a lot of this RPC requests. We will improve this and make it even faster, so it's not a blocker in a future version. So keep follow our release note and our YouTube channel to be updated. But now I think it's already a really amazing improvement. Yeah, 100 humans per second is not fun at all, but yeah, I have to admit it's much better than 4 humans per second. And yeah, what's nice, we already performed 20,000 calls for this getToken details, and you can see that cache hit is 0. It means that every time we do a call, we store it in the database. So in case it's needed again during the indexer, we don't request it. It looks like there are no duplicated tokens in created clauses. It's actually interesting. And yeah, let's talk about cache a little bit more now, because I don't want to stop the indexer and we perform this request again, because it's consuming my RPC credits and like it costs money. And yeah, let's continue talking about this. Okay, while I was going to grab a glass of water, it actually finished, and this is largely increasing because it doesn't progress, and it was something about historical sync from block 0 to the head took around 6 minutes, like 6 minutes and a half, I think, and it was 115 humans per second. Not impressive, but if you hover over here, what's exciting, you can see that it saved 28 hours of processing time, but by parallelizing effective calls. So if we called all this 96,000 getToken details requests one by one, how we did it initially, it would take us 28 hours to finish this answer. This is crazy. And just going down to 5 minutes, even though number of events per second is not that big, but it's still 6 minutes to walk through the whole chain and yeah, and get a lot of token details and the token metadata phrase. So the question is, cache, how we do this again and don't spend all our basic credits. To do this, you can click this sync cache button, and what it does, if we go to the our indexer now and open this sidebar, you can see that now there is this .envio file, and there is a cache directory, and the T3 file is all the cache data. So all the tokens we requested are now cached and stored in this file. You can use it locally for local development. Also, what you can do, you can go to gitignore, remove cache line from here and commit it to GitHub. So anyone else who opens this index, like calls it from GitHub and runs it. Let's do this. Restart it from scratch. Anyone who like calls this indexer and runs it, for example, it might be hosted root as well. They'll get this data from cache. So you can see that we don't perform any calls anymore. We get it from cache, and it's amazing. This is really nice. So there are quite a few limitations that you can't upload a cache from a running hosted service indexer. So you need to accumulate it locally and populate it by clicking the sync cache button from the development console. Also, this is not really nice to store on GitHub. Like, it pollutes the history, and also GitHub doesn't allow big files. And yeah, this might be a problem. And yeah, so just some limitations of this solution. But our main goal here was to solve a previous problem with this manual JSON cache files. Also, some users used MySQL databases, and all of them were much further than this. And this is already works quite nice for a medium size effective back calls. So you can see that it worked quite nice. And yeah, at some point I started calling, and this is a question for me to investigate after I finish recording this video. But still, it was quite fast to finish listening to the half hosted chain. Okay, a few tips here which I can give. So it's getting nerdy and nerdy. You can see that the cache stored is not in the most optimized way. Like, there are quite a lot of duplicates. Like it doesn't make sense to store every field like this. What you can do some optimizations and change how the data is stored in the cache. And to do this, you can use Suri schema library things. And for example, what we can do, instead of storing this input as an object in my cache, we can use tuple schema factory. And for example, we want it still to return it as an object type. Change it to return type. You want it to be returned as object type, but under the hood actually be to be a tuple. And to do this, and I use some plugins. So this is one thing. Unfortunately, I think it won't work for output, but I might be wrong here. But let's not do it for output, just mostly for input. Also, a question might be like, this is a single chain indexer. How you do this for multi-chain indexers? And an answer is, like, we have a client. So for multi-chain indexer, you would create a client for every chain, and then you pass a chain ID, and with chain ID you call it const client get client my G ID. I've tried this out to be written by you, and that will be something like something like this. And you add a checkmark with each chain ID it is. So this is think it what I want to tell you about Effective AI. If you have any question, definitely pop up on our Discord channel or Telegram, or leave comments and questions directly on YouTube. We are definitely open for feedback, and we are definitely keen and improve even further. If already can see that just in a year, the specific indexing case was improved from 28 hours estimately to 5 minutes, like 5-6 minutes, and also can be improved even further by parallelizing this calls. So for example, if you have currently we do request a token metadata for token 0 first, and then for token 1. It can be improved even further by using promise all. Also, it can be improved on our side by requesting data even faster, and also like we are definitely cook you more exciting, nice API, so it will make your life even easier. Like a few points you'll definitely solve is like creating all these clients is definitely a not nice experience. So we will try to provide you a much better API in the future. But now with Effective AI, Effective AI originally is a low-level tool to allow external calls with any flexibility you want, and actually does really well. So please use this and create really wonderful, amazing indexers which blow people's mind, because previously it wouldn't be possible before without hyperindex. Yeah, cheers. Thank you. Like if you watch until the end, you're really amazing. We'll love you, and hopefully see you in next Shipper Logs releases and episodes. Bye.